for. So we're looking at, as a result of being outside for a prolonged period of time, a swing set rusts. This is actually referring to a chemical reaction that we looked at in the previous set of notes. You've already written the skeleton equation in a previous set of notes, but we'll just get practice doing it again. Okay. We see that this rusting occurs when solid iron reacts with oxygen gas in the air to produce solid iron 3 oxide. So I know that solid iron is reacting with something, so that is a reactant. It's also reacting with oxygen gas as a reactant to produce solid iron 3 oxide as a product. Okay, so let's write the skeleton equation. I've got iron as just an element, so I'm going to write its symbol. It says that it's solid. Plus oxygen gas. Oxygen is an element, so I need to write it simple. But remember, it's one of those diatomics, so I have to write O2. Gas yields iron 3 oxide. And remember, iron 3 oxide, that is a compound, and it is ionic because it starts with a metal, but also the Roman numerals should tell you that. So you have to balance your charges. So iron 3 means it's iron with a 3 positive charge. It has lost 3 electrons. And then oxygen will form a 2 minus charge by losing 2 or gaining 2 electrons. It's in group 16, so you can get that from there as well. Swap and drop, you get Fe2O3. So I'm going to write that over here. Okay, and it's a solid. All right. So to balance, you've got iron and oxygen. All right. There's only 1 iron represented on my reactant side, and there are 2 irons represented on my product side. We've got 2 oxygens represented on my reactant side, and 3 oxygens represented on my product side. Okay. You can kind of choose your battle, see which one you want to deal with first. I will generally save, see how iron is all by itself and there's no subscript or anything, it's just 1 iron. I know I can make that equal any number I need to at the very end, just because it doesn't affect anything else. So I generally will save these kinds of elements or whatever for last. So I'm going to go ahead and try to tackle this 2 and 3 because I know that's going to probably be more complex. Okay, so 2 and 3, if you go back to the previous example, there's a couple ways you could do it. I'm going to do it the second way. All right, so we've got 2 and 3. I know that I can make both of those equal 6 by multiplying this guy by 3 and this guy by 2. So now I've got 2 times 3 is 6 oxygens. It doesn't affect my iron. I've got 2 times 3 is 6 oxygens. However, now I have 2 times 2 irons, that is 4. So my oxygens are balanced. Now I need to have 4 irons on my reactant side because I have 4 in my product side. So since that's just 1, I can put a 4 there. Now everything is balanced. Let's check the work. We've got 4 irons, 6 oxygens. 2 times 2 is 4 irons. 2 times 3 is 6 oxygens. And we can check to make sure that we are in the lowest whole number ratio. And 4, 3, and 2 cannot be reduced any further. So that is complete.